The National Electrical Code, or NEC, does not mandate the use of knockout bushings to protect low-voltage cable, specifically FPL cable used for power-limited fire alarm, or PLFA, circuits when these cables are installed free air into metal boxes. The NEC focuses on preventing physical damage to conductors and cables. Article 300.4 F in the NEC addresses protection against physical damage. It states that where cables or raceways pass through a metal box or enclosure, they must be protected from abrasion and the edges of the opening. This protection is typically achieved through the use of fittings, bushings, or other approved methods. However, the key factor is whether the cable is susceptible to abrasion or damage from the opening's edge. With FPL cable installed free air, meaning it is not tightly pulled or stressed against the edge of the knockout, the risk of abrasion is minimal. In situations where the knockout edge is particularly sharp or rough, or where the cable is subject to movement or vibration, it would be prudent to install a bushing or fitting to provide additional protection. This decision often relies on the electrician's professional judgment and assessment of the specific installation conditions. The type of enclosure also plays a role. For example, a cast metal box with smooth, rounded knockouts poses a low risk of abrasion compared to a thin-walled metal box with stamped knockouts that may have sharp edges. The NEC also contains articles dedicated to specific wiring methods, such as Chapter 7, which covers special conditions, including fire alarm systems. These articles provide additional requirements and guidance for the installation of FPL cable and other wiring methods. The requirements in Chapter 7 must be followed in addition to the general wiring requirements found in Chapters 1 through 4. In the case of FPL cable, the NEC specifies requirements for listing, marking, and installation. It also limits the voltage and current levels permitted in PLFA circuits to enhance safety. When installing FPL cable, it's crucial to support the cable properly to prevent strain on the conductors and terminations. Cable supports, such as cable ties or struts, should be installed at intervals specified by the NEC. These supports prevent the cable from sagging or coming into contact with other objects that could cause damage. Another important consideration is the bending radius of the cable. The NEC specifies minimum bending radii for different types of cables to prevent damage to the conductors and insulation. Exceeding the minimum bending radius can cause stress on the cable and potentially lead to failures over time. Cable penetrations through fire-rated walls or floors require special attention. The NEC mandates the use of fire-stop materials to maintain the integrity of the fire rating. Fire-stop materials prevent the spread of fire and smoke through openings created for cable penetrations. These materials must be listed for the specific type of cable and the fire resistance rating of the wall or floor. When terminating FPL cable in devices such as fire alarm control panels or initiating devices, it's essential to follow the manufacturer's instructions. Proper termination techniques ensure a reliable electrical connection and prevent loose connections that could cause malfunctions. The NEC also addresses grounding and bonding requirements for fire alarm systems. Grounding provides a path for fault current to return to the source, reducing the risk of electrical shock. Bonding ensures that all metal parts of the system are electrically connected, minimizing voltage differences that could create a shock hazard. Article 250 in the NEC provides detailed requirements for grounding and bonding. It covers topics such as grounding electrode systems, equipment grounding conductors, and bonding jumpers. Compliance with Article 250 is essential for ensuring the safety and reliability of electrical systems. When working with electrical systems, it's crucial to use the correct tools and equipment. Insulated tools protect against electrical shock, and appropriate testing equipment verifies the integrity of the wiring. Before working on any electrical circuit, always energize the circuit and verify that it is energized using a voltage tester. Lockout/tagout procedures prevent accidental re-energization of the circuit while work is in progress. Safety is paramount when working with electricity. Always follow safe work practices and comply with all applicable codes and standards. Electrical work should only be performed by qualified individuals who have the necessary training and experience. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Staying current with the latest edition of the NEC is essential for ensuring compliance and promoting electrical safety. The NEC is a comprehensive document that covers a wide range of electrical topics. It's important to consult the NEC for specific requirements related to your installation. In addition to the NEC, local codes and ordinances may also apply. These local codes may impose additional requirements or restrictions on electrical installations. It's important to check with your local authority having jurisdiction, or OJ, to determine the applicable codes and standards in your area. Proper planning and design are essential for a successful electrical installation. Before starting any work, develop a detailed plan that outlines the scope of the project, the materials to be used, and the installation methods to be followed. A well-designed electrical system will be safe, reliable, and efficient. The NEC provides guidance on various aspects of electrical system design, including conductor sizing, overcurrent protection, and voltage drop. Following these guidelines will help ensure that your electrical system meets the required performance standards. Regular maintenance is essential for keeping electrical systems in good working order. Inspections should be conducted periodically to identify any potential problems or hazards. Maintenance tasks may include tightening connections, replacing worn components, and testing safety devices. A well-maintained electrical system will be more reliable and less likely to experience failures. Troubleshooting electrical problems requires a systematic approach. Start by gathering information about the problem and then use a process of elimination to identify the cause. Common electrical problems include open circuits, short circuits, and ground faults. Using appropriate testing equipment and following safe work practices will help you troubleshoot electrical problems effectively. Electrical safety is a shared responsibility. Everyone who works with or around electricity has a role to play in preventing accidents and injuries. By following safe work practices and complying with applicable codes and standards, you can help create a safe working environment for yourself and others. The NEC is a valuable resource for anyone involved in the electrical industry. It provides the guidance and information needed to design, install, and maintain safe and reliable electrical systems. By understanding and applying the principles of the NEC, you can contribute to the safety and well-being of your community. Remember, when in doubt, consult with a qualified electrician or electrical engineer. They can provide expert advice and assistance to ensure that your electrical installation is safe and compliant. In the specific case of low-voltage FBL cable installed free air into metal boxes, while the NEC doesn't explicitly mandate knockout bushings, always consider the specific installation conditions and use your professional judgment to ensure the cable is adequately protected from physical damage. If there is any doubt, it is always best to err on the side of caution and install a bushing or fitting.